In this day and age of agile manufacturing, production processes need to be flexible and designed based on the premise that changes will be made along the way. Yamaha Motor is putting forward its next-generation transfer platform capable of flexible production line operation for sophisticated and efficient manufacturing. One often overlooked aspect of the production process is the time required for inter-process transfers. In other words, this is essentially time that has no value. Reducing this time as much as possible is the key to achieving an efficient production process. LCMR200 uses robots for such transfers to almost completely eliminate time with no value, thus achieving production processes without waste wherever possible. LCMR200 is a conveyor system that uses linear motors in place of conventional roller conveyor or belt conveyor systems. It builds on the traditional approach of flowing objects by utilizing robot technology to move them anywhere, resulting in a more flexible and high-efficiency production line. Robots are servo-controlled, which means slider speed, acceleration, deceleration, and stopping position can all be controlled by changing numerical values. This system eliminates the need for parts used in conventional conveyor systems, like stoppers that stop the movement of workpieces or sensors that detect when they arrive. Workpieces decelerate smoothly to a stop, so there is no need to worry about workpieces shifting when coming to a sudden stop. Production lines based on LCMR200 have a greater yield and can improve profitability by achieving high-speed transfers and eliminating wasted time for inter-process transfers. Its modular structure is one of its key features. Production lines can be built by connecting modules up to the required length. Connections are made easy with the use of connection plates for mechanical positioning and connection units to link communications through all modules. A line offering excellent reliability and reproducibility can be set up quickly, helping to cut back on the time required for design. Modules can be connected up to a maximum length of 25.5 meters, consisting of 64 sliders. Adding or removing modules is easy and provides flexibility when changing the layout of the production line. Whereas a controller was required for each module with the previous LCM100 model, the LCMR200 has the motor driver incorporated inside the module itself, allowing control from a single YHX controller. The module height is also around 30% lower, resulting in a system with a compact design. The system can also be combined with circulation units to achieve both vertical circulation and horizontal circulation layouts. This means a flexible line can be set up to suit specific applications. A direct drive system that moves the actual sliders has been used, achieving a maximum speed of 2,500 millimeters per second and capable of acceleration up to 1.3 g. A repetitive position accuracy of ±5 micrometers and tolerance between sliders of ±30 micrometers results in high-speed transfers and high-precision processes. With a maximum payload of 15 kilograms, the system is capable of handling a wide range of workpieces. Servo control ensures that all sliders are capable of independent operation, so they can all move individually at exactly the required time. Pitch feeding over short distances ensures high-speed movement, even in high-density processes, which makes transfers efficient in processes with different takt times. A fully absolute positioning system has been used, eliminating the need to return to origin. All slider IDs and current positions are recognized when the power is turned on. Operations can be started and stopped easily, so there is no time loss even when starting or restarting. Sliders are also supported directly with a high rigidity guide, so operations can be conducted right on the production line. There is no need to retract parts to a separate area or insert locating pins to secure workpieces like with conventional conveyor systems. This cuts down on transfer time significantly, leading to a shorter takt time. The system has been reduced in size by around 30%, allowing operation of more compact production lines. The result is a greater throughput and an increase in the number of lines, with yield increased 2.8-fold in some cases. In cases where there are multiple identical processes, conventional conveyor systems could only transfer workpieces in one direction, so multiple workstations were required to perform work. The LCMR200, however, can operate in reverse to allow process sharing. This minimizes wasted costs and means production lines can be made more compact. Processes consisting of 3-axis Cartesian robots on conventional conveyor systems can now be performed by 2-axis Cartesian robots, as the LCMR200 operates as the X-axis. This not only reduces costs associated with an additional robot, but also helps save space. Even when a process involves multiple workpieces on a single slider, operations can be switched over easily, making high-mix production simple. Changing the stop positions on conventional conveyor systems requires changes to be made to the positions of stoppers, sensors, and other components, which can take time to complete setup changes. The LCMR200 only needs a different program to be loaded. There is no need to make any hardware changes. A more flexible approach can be taken for changing processes to suit product types, such as skipping unnecessary processes. The result is a significant increase in the utilization ratio of high-mix production lines. Adding or changing processes can take a lot of time for conventional conveyor systems once production lines have been built. The modular structure of the LCMR200 allows a flexible approach in such cases, thus minimizing costs and time associated with setup changes. Taking a modular approach to each process using LCMR200 also has a significant impact on efficiency when setting up new production lines. Instead of designing new lines from scratch, production lines can be built using common modules, keeping the amount of new designs to a bare minimum. This approach also helps to minimize design man-hours and production costs. Another benefit is the reduction in required spare parts with the use of process sharing. When using a circulating production line layout, Yamaha genuine circulation units are available as standard to help reduce the man-hours required for designing customer circulation systems. Using these units helps achieve reliable production line operation. The accuracy of transfer sections must be constantly maintained to ensure reliable operation of circulating lines. Yet there are cases where deviations, such as bases deflecting due to external factors or expansion and contraction caused by heat, can make maintaining accuracy difficult. Yamaha genuine circulation units constantly maintain the accuracy of transfer positions with the use of 2 high rigidity guides and a high-precision linear scale. These ensure reliable operation of production lines. End plates are calibrated at Yamaha's plants before they are shipped out. After being delivered, simply install them onto production lines and run teaching to quickly finish calibrating. Even with long production lines, LCMR200 can be controlled with a single YHX controller regardless of how many modules are installed. One of the main features of the YHX controller is its stacking modular structure, which comprises the host controller unit, driver unit, and driver power unit. The control power supply, motor drive power supply, high-speed network communications, and safety circuits all have a stacking modular structure, which reduces wiring immensely. This eliminates wiring between units, leading to a significant reduction in wiring costs and wiring man-hours. Lines are controlled by the YHX standard profile, which allows for simple and intuitive control, even when operating multiple sliders, to drastically reduce the amount of man-hours needed to set up a line. The positioner type method of control involves preloading the position, speed, acceleration, and tolerance in YHX as an operation pattern, and specifying which slider to operate. It is also capable of direct control, where the target coordinates are designed from the host PLC each time. Slider transfer accidents that occur in the circulation section can also be prevented through generated errors. Accidents such as sliders ejected without receiving circulation module, or sliders accidentally ejected in the reverse direction, can be avoided before they occur with an error generated before the robot starts operating. This allows safer software to be designed. Individual IDs for each slider can also be recognized for optimum traceability control. All sliders are recognized when the power is turned on, and their current position is always monitored in real time, even when the sliders are moving. Slider IDs can be linked to workpieces or serial numbers to identify or trace specific products, IDs of used jigs, or part IDs. The current position of sliders moving between processes can be output to identify slider positions in real time. This means the cause of any faults that occur can be investigated without taking much time, allowing the cause to be identified quickly and improvements made to the affected process. Robot Vision RCX IV2 Plus is also ideal for traceability control. The code recognition function is capable of reading QR codes, data matrix codes, and barcodes. It scans the QR codes of workpieces for serial numbers and links them to LCMR200 slider IDs to provide more effective traceability control. RCX IV2 Plus is a robot controller integrated vision system. Simply installing the RCX IV2 Plus unit on the controller provides centralized operation of robot control, image processing, lighting control, and more. It is much easier to integrate with peripheral devices compared to typical robot vision systems. The robot program covers all operations, from acquiring coordinates to controlling lighting. It is simple and easy to use with no need to worry about communications time lag. This means the time required for setup can be reduced significantly. In cases when workpieces are not detected during searches, the lighting can be changed with a single command to run the search again. Light intensity can be adjusted between 0% to 100% with lighting conditions changed before simply running the search again. The blob search function allows high-speed detection of irregular shape objects. Compared to industrial products, it is ideal for picking objects with a wide tolerance in shape or size, such as food and clothes, inspecting presence of objects, or high-speed counting of multiple workpieces. Controller support software RCX Studio 2020 includes multiple RCX IV2 Plus program templates. Simply follow the step-by-step operating processes without entering any commands to automatically create base programs such as pallet picking, dispensing work, or gripping deviation corrections. This can significantly reduce the time required to create programs. Mounting multiple cameras also provides a flexible approach for supplying a range of different parts. This caters to a range of applications, such as the first camera mounted downward to search for workpieces, a second camera mounted upward for workpiece positioning and angle corrections, and a third camera mounted downward for placement position corrections. Up to 8 cameras can be connected, which means a camera for code recognition can also be added. An automatic image saving function is among other functions that are also available. It is a truly reliable support system that is only possible from a robot manufacturer. Next is the YKTW Orbit Type SCARA robot. The main features of the YKTW SCARA robot are that it has a sailing mount configuration and can rotate around 360 degrees. It can access any point immediately below and within full range of the robot, giving users freedom of layout design without being limited by pallet or conveyor placemats. It also provides underpass motion, where R-axis of the tip passes directly below the main unit. This limits the installation width to 492 mm, making it ideal for confined spaces. A conventional SCARA robot cannot access areas around its center, meaning larger units have to be used when handling pallets with multiple different sizes. The Orbit Type YKTW can handle changes in pallet sizes, so a much more compact unit can be used. The YPX series of robots is designed specifically for pick-and-place operations, ideal for high-speed supply of small parts to production lines. The YPX lineup features a total of 6 models with 2-axis, 3-axis, and 4-axis types. The YP220BX in particular has a compact design that is just 109 mm wide, meaning multiple robots can be installed in narrow spaces where several types of parts need to be supplied, such as with assembly processes. With a 0.45 second standard cycle time, it can improve productivity drastically. Wiring and piping also pass through within the main unit to achieve a layout with minimal interference to surrounding robots. The combination of a linear conveyor system and 2-axis YPX in particular allows for similar movement to a 3-axis robot, which can greatly broaden the scope of applications. It is clear just how space-efficient the YPX is compared to the required installation space of Cartesian robots or SCARA robots. This is the GX single-axis robot. All models use ground ball screws with JIS accuracy Class C5, delivering a high ±5 micrometers level of reliability and durability. All axes and the main unit top base are lined with a dust-proof stainless steel sheet as standard for excellent durability, helping to prevent contamination by foreign materials from outside. The robot can also be used in a clean room environment by simply adding a suction port. The motor direction and mounting orientation can also be changed to suit any application. Next, the YKXG SCARA robot. The YKXG series of SCARA robot has a completely beltless structure, which greatly reduces waste motion and helps to maintain a high level of accuracy for an extended period of time. It also ensures a lengthy maintenance-free operation period without worrying about belt elongation or changes over time. The tip rotation axis uses the speed reducer direct coupling structure that ensures the high-speed operation, even under offset conditions. Other models in the lineup range from the compact model with a 120mm arm length up to the large model with an arm length of 1200mm. Wall mount models, dust-proof and drip-proof model, and clean room models are also available to suit customer requirements. And here is the YKXE SCARA robot. The YKXE is the low-cost, high-performance model offering an ideal balance of superior operating performance and affordability. With a 4-model lineup ranging from 400mm to 710mm arm lengths available from 798,000 yen, its affordable price point helps to reduce costs required for equipment investment. These models form the core of Yamaha Motor's next-generation transfer platform that is delivering value-added versatility to transfer processes and is helping to increase customer production capacity and cost competitiveness.